No pro golfer has ever achieved the modern-day Grand Slam of golf by winning 4 majors in the same year. Tiger Woods had an amazing year in 2000, winning the last 3 majors. He dominated at the US Open and Open Championship, which just happened to be Pebble Beach and St. Andrews. And then he had a wild victory at Valhalla for the PGA. He had a birdie putt on 18, which he had to make, which he did, and then he forced a 3-hole playoff. Remember his birdie putt on the first playoff hole? In 2001, he won the Masters. That made it 4 in a row. So everybody was like, is that the Grand Slam? And it was no, because it's 2 different years. But he did win 4 straight over 2 years from 2000 to 2001. So they ended up calling it the Tiger Slam. It was an amazing feat which has not been achieved to this day. Welcome back to another episode of Polymer Materials Ask Dr. Paul. Today we're going to highlight property information of 4 common polymer material types. So when your boss talks about plastics, elastomers, TPEs, and thermoset plastic property differences, what do you need to know? In previous That's Working Knowledge video, we described how rigid and flexible thermoplastics and thermosets can be called plastics, elastomers, TPEs, and thermoset plastics. We did the fruit analogy in which we said plastics are like apples and elastomers are like oranges. They're different and they don't compete. But thermoplastic elastomers or TPEs compete with elastomers. So if elastomers are an orange, TPEs are like tangerines. And then switching to the rubber side, if plastics are like an apple, then thermoset plastics are like a high-end apple. If we look at the table on our screen, we can discuss property differences of our big 4 polymer material types. Plastics and elastomers are totally different. Plastics have high TG, high modulus, low strain, fast cycle times, and they're melt processable, which means they can be reground and remolded. Elastomers are thermoset, long cure, cannot be recycled again and reused in a molding operation. Let's center on the flexible polymers. We'll talk about similarities and differences. Elastomers and TPEs, they're similar in the sense they're flexible, they have low TGs, they have low modulus, they have high strain. We've talked about 1000%. But the difference, one being thermoset, the elastomer, and one being thermoplastic, the TPE, shows up in the cycle time. So elastomers have that 3-minute cycle and they're not regrindable, where TPEs have that faster cycle and we can use them in flexible situations. The shortcomings and why we don't use them all the time, even though they have lower costs due to faster cycles, is because that plastic component brings about compression set values that are inferior. So sometimes we just have to use true elastomers, but sometimes we can get away with a TPE like a soft touch tool handle or toothbrush handle. With respect to the rigid polymers, we have plastics and thermoset plastics, and they're similar in many ways. High TG, above room temperature, high modulus, unfilled could be 1000 megapascals, and these materials can be highly filled, and that modulus value can go way up. They're brittle, they're low strain materials, and one being thermoplastic, one being thermoset, both being rigid. The plastics have the short cycle, 20-second, where the thermoset plastics have the longer cycle times with molding, maybe 3 minutes. And that's going to cost you more money, so you got to get something out of it. The thermoset plastics, as we've said before, what you get is typically improvements in chemical resistance and even heat resistance. And just like the elastomers, the thermoset plastics, you can't regrind them and reuse them again. Knowing property differences of the big 4 polymer material types, plastics, elastomers, TPEs, and thermoset plastics, that's working knowledge. Remember to like, subscribe, turn on notification, and even share if you appreciate the content. I'm Paul Nash for Polymer Club's Ask Dr. Paul. Thanks for watching.